All right, so now it's 3:02, so let's get started. Hi, everybody. Thanks for joining. This is 𝗗𝗲𝗽 from Nirmata, and really excited about the topic for our meetup today and having this session with our friends at JFrog. So want to introduce Deep from JFrog, who's going to cover how to approach security with Helm charts and how Helm charts enable better security best practices for application management. And what I'll do after that topic, I'll also talk about configuration security as it relates to Helm charts or also YAML configurations. So with that, let me hand off to Deep, and Deep will introduce himself and kick things off.
All right, thank you so much. So as mentioned, I'm here to talk more about Helm charts and how they can create reproducible security. Before I jump into my talk, I did want to let you know that all the slides that you're going to see today are available at this link, the bit.ly link that says ChartCenter August. You can also scan the QR code. One cool thing about the link is if you fill out your information, you're automatically entered to win a Nintendo Switch. And everyone who fills out the information also gets a cool JFrog t-shirt. So the one pictured here is our Iron Frog, which is also, which is consequently one of my favorite. So I'll put this back up at the end if you can't, get this link now. A little bit about myself. My name is 𝗗𝗲𝗽, and I am the community product manager at JFrog. What that means is I get to work on all the really fun, free, and open source adjacent stuff that JFrog engages in with the community. I'll show you a little bit about one of the free products that I manage called ChartCenter, which is related to Helm chart security, but we'll look at that a little bit at the end. I wanted to tell you that, should you want to contact me after this talk, please do. I love talking to developers. You can tweet me at 𝗵𝗵𝗽 or email me at deepd@jfrog.com. Again, I'll put this up at the end in case you don't have it now. Cool. Okay, so today's agenda, we're going to start with a short sort of introduction to some of the changes that have happened with Helm 3. Then I'm going to give you a little bit of a step-by-step overview of what it means to secure a Helm chart. We're actually going to go through a process that I kind of like to refer to as a blueprint for Helm chart security. And you'll see what each of those steps looks like. Near the end, I'll show you some new tools being used in the Helm community. And at the very, very end, we'll do Q&A. So if you have any questions, you can ask them then. Also, I don't usually pay attention to the chat window while I'm sort of talking. So if anything happens, like sound issues, if someone just shouts out, I'll make sure I can fix any issues that come up. Okay. So we're going to begin the discussion by providing a bit of history around Helm and how we got to where we are today. You might have heard that Helm pretty recently moved from an incubation project to a fully graduated project within the Cloud Native Computing Foundation. So this means that Helm has reached a certain level of maturity. And if you're new to Helm charts, this is actually a really, really good time to dive in. I was reading a statistic that said 70% of Kubernetes deployments are now using Helm. And in the next slide, we'll talk a little bit about why that is. So Helm is basically a package manager for Kubernetes. Helm was introduced at KubeCon in 2015. So it's a technology that's less than 6 years old. And right after it was released, about a year after, Helm 2 was published in the middle of 2016. And then it was merged under Kubernetes as a sub-project. Originally, with the way Helm started and developed, there were a lot of server-side components that were brought over from Helm 2. And when Helm 2 became a full-fledged CNCF project in 2018, Helm 3 work began. And at this time, with the start of the Helm 3 conversation, the community was already aware that there were some server-side components that were potentially causing vulnerability or security issues. I think again, if you're familiar with Helm, you'll know that I'm referring to Tiller. And we'll talk more about Tiller on the next slides. Helm basically assists with installing Helm charts on Kubernetes. And afterwards, as a package manager, you can use it to upgrade, to roll back the installation. With each sort of subsequent version of Helm, there are new and more useful and more relevant commands being created. So what's really important to know is Helm can help you manage the state of the application and get a sense of where the application is in its current life cycle, right? So from the deployment history to the behavior of the clusters, it's all things that you potentially manage with Helm. So as I mentioned, the single biggest improvement to Helm 3 was the removal of Tiller. Tiller was a legacy component that had been created before Kubernetes had RBAC for permission management. And Tiller caused security issues because of how permissions were handled with root access. With Helm 3, the new architecture, Helm interacts directly with the Kubernetes API, and you manage permissions using RBAC directly with the Kubernetes API, and Tiller has been removed. A few other improvements that have come with Helm 3 are dependencies. They used to be declared in your requirements.yaml file, but now they're part of your chart.yaml file. There are also releases and namespaces. So release information in Helm 3 is now stored in the same namespace with a secret as the storage mechanism for all the release information. There's also a three-way strategic merge patch in Helm 3. Which is just a much more efficient way to merge these changes. In Helm 2, it was a two-way merge. Another update with Helm 3 is OCI registries for charts. This is an experimental feature, but Helm 3 is exploring the use of OCI for storing and distributing your Helm charts. And this also plays a little bit into the security conversation. Next is chart validation. There's a JSON schema that the JSON schema support has basically been added to the charts to make sure to define a structure for the values supported by the chart. And the Helm CLI then uses the schema for validation of the values that the user provides. There's also improved CRD support, and there is a new type of chart called a library chart, which basically is just used to define like dependencies in other charts. A few new commands for Helm 3. And again, these really point to the fact that Helm is really focusing on better monitoring. So as Helm does its job to sort of manage the life cycle of your application, you can see with these new commands like Helm history, you can get a full history of the releases, with of course the chart name and the application version, the description. And I think one thing that I really like about Helm, the more I learn about it, is the ease of accessing a lot of this metadata. Okay, so now we're going to jump into the security part. But before I do that, for those of you that are maybe a little less familiar with Helm, I think it's important to talk about the structure of a basic Helm chart. And this structure can change dramatically, but when you create a Helm chart for the first time, there's a few things that you should sort of pay attention to, especially as you start learning about the security aspect. So before I dive into each of those sort of focus areas, what I think is important to highlight is what Helm really brings to the table here is immutable configurations, right? So you can get true configuration as code, and the immutability kind of puts everything under your control in one place. So in the context of security, this control is essential. When you publish a Helm chart, you can take care of all the security issues beforehand. And this is really where the immutability helps. So you'll see later down in this presentation when I talk about the fact that once you have your environment secured and your configuration set up with your Helm chart, you can basically send this Helm chart to teams around the world, right? So you might have a QA team in one office and and a production team in another office and maybe a test feature branch somewhere else. These Helm charts really help you make sure that the environments are reproducible, and this is definitely a benefit to security. The other thing that I want to call out that I did mention is using a trusted source and the metadata to track sort of the life cycle of the application. So transparency is pretty important as well. You'll see when I show you security that Helm has a way to verify sort of the authorship of a chart using signatures. And trust is something you should just pay attention to in general when you're using any kind of package or third-party, dependency. And Helm makes it easy to sort of get the chain of custody of where that chart came from. Okay, so as I talk through security again, I want you to understand what it means at each step. So we're going to kind of mimic in this presentation what like creating your first chart looks like. So first, it's pretty straightforward to create a Helm chart. You just do, once you install Helm, you can just do Helm create and then the name of the chart. Here I'm calling it my demo chart. In my demo chart, these are the 4 things I want you to pay attention to. There is a chart.yaml file and a values.yaml file. And then there's 2 folders here that I'm showing you. There's the templates folder and the charts folder. The chart.yaml file, this is basically where all the metadata that describes the chart live. So if you are giving, you're describing what this chart does, you're versioning your chart, everything around describing this particular application will live in your chart.yaml file. And important to call out, again, in Helm 2, your dependencies were declared in a separate YAML called requirements.yaml, and now they have been moved into the chart.yaml. So just something to remember. Next, I think this is probably one of the most important things that's part of a Helm chart, which is your values.yaml file. So this is where you set all your default configuration options. When you create a chart for the first time, you're going to see a lot of the key value pairs. They already exist in there for you. And depending on how you build out your application, you can update those key value pairs in your values.yaml file. The other thing is when you install a chart, you can actually, the user can set their own values and override the default ones. So there's some cases where you might actually want to override what's part of the default values. It might have to do with resource quota constraints. It might have to do with maybe using a different version of a database. Values.yaml, super important. Next, I want to highlight the templates folder. So the most important piece of sort of the Helm puzzle, besides the values YAML file, I think, is this concept of templates. Inside the templates folder, this is where Helm finds all the YAML definitions that set up your various services. So if you sort of already have a existing Helm application, and then maybe you're creating a new Helm chart from scratch, inside your templates folder is where you would maybe move over all those configurations, all the YAML files in the existing application. By default, you have a service.yaml and a deployment.yaml and a few of these other ones that you see here. YAML files can be, many YAML files can be named in various ways. You'll find all of those within this templates folder. Okay. Service.yaml is basically the default name for where your services are defined for pods, and the deployment.yaml basically generates the metadata around each deployment. The last thing I just want to note here is the charts folder. So inside the charts directory is where you would store any subcharts. Okay, let's talk more about security. Okay, so the reason we're here is basically to learn how to harden a Helm chart. And I have basically listed a bunch of different steps that you need to pay attention to and kind of understand what the security best practices are around each of the steps. If you are familiar with Kubernetes, you will notice that a lot of these steps actually apply to Kubernetes. Helm and Kubernetes security are interrelated. In some cases, some of these steps, they are not separate. But it's important as you build a blueprint for Helm security that you actually obviously know how to manage security for your pods and your Kubernetes setups. So as I walk through this, you'll see how each piece applies to the whole ecosystem. I've tried my best to break up these concepts into items that you can follow. When you're using a Kubernetes application, not all of these steps are going to apply every time, and also not all of these steps are going to be applied in the order that I'm describing them today. But I think this will give you, I think the presentation will just give you a good sense of how to set up your own sort of blueprint for success. Okay, so this is my handy dandy little graphic that's going to walk us through it. So before you, start setting up this Helm chart to make it secure, I think one thing that I really want to point out is it's important to set resource quotas. So, your application is usually, it's going to run on a virtual machine, and it is best practice to set up the resources and a quota to make sure that this application is not taking over all the memory on your VM. So this is just a kind of a preliminary step, I think something important to call out. And you can't override these quotas if you are installing this, if you're overriding the values file when you do the installation. This is a real world example of what the, setting resource quotas, basically what it looks like in the 𝗗𝗲𝗽 chart. And the next thing I just wanted to talk briefly about is checksums. So, if you're familiar with checksums, what you're looking at here is a hash. It's a string of characters that verify that any information that was transmitted or stored is the exact same file or the same information that was intended to be sent. So, for example, if I am the author of a Helm chart and I send it through the web to you, anything could happen in that transmission process. Some pieces of data could become corrupted. Maybe there's some kind of man-in-the-middle attack and somebody interjects something in the files before they get to you. Checksums are a digital handshake. If any content in the file is changed or degraded in any way, the hash changes, this checksum will change. And this means, the checksum that was bundled with the chart that I gave you won't match the checksum that you got at the end of the day. And I'll show you that you can verify this as a user. And so you'll know that if there's a checksum mismatch, you'll be alerted. But essentially this is telling you that something in the file changed that the author didn't intend. Okay, so here's kind of where I talk more about how these checksums are used. If you are familiar with signing, keys, in Helm, you can sign keys different ways. The way that I like signing keys is using the GPG format. And Helm also has a GPG plugin, which actually includes a passphrase when you're signing your chart. So the passphrase helps make this even more secure, and you can, if you're on a Mac like me, you can install this plugin. You can install GPG with brew install, but then you can install the plugin with this Helm plugin install command here. You'll create your public-private key. You'll use GPG gen key to sign it, and then you'll provide a passphrase or a password. Once you create your public-private key, you're going to see that it's generated this fingerprint. This fingerprint has my contact information that I put in, deep data, my email, and that verification string right there. And when I create my Helm chart for the first time, and I want to package it all up, I can use this signature. One thing to know, if you're using GPG 2.1 and above, the name of the file that stores your key rings has changed. So you need to use this GPG export secret keys command. This will change your file back to the old format. And then you use a command like helm package sign key, give it a name, point to your key ring, and then give it the name of the chart. So again, demo chart, and it'll spit out these two files. TGZ is your packaged Helm chart, and the tgz.prov is a file called your provenance file. And provenance is the file that has the checksums. It's the file that we use to track lineage. So when a user gets this Helm chart, they can do a Helm verify and the name of the chart, and they're going to get this fingerprint that I showed you, a minute ago. This is going to confirm that the hashes haven't changed. It has the author information that I provided. And again, this is a good way for you as a user to know that you got what was intended. All right. The next thing to talk about is pod security and RBAC. So again, if you're familiar with Kubernetes, this is no surprise to you. Creating a security policy around your pods is pretty important. You can control the state of your pod, set different permissions for different pods, and the best practices include making sure that you disable privileged containers, making sure that your system is read-only, so somebody who's accessing these pods later isn't overwriting things. You want to prevent privilege escalation. It's only the admin that you want to give this escalation privilege to. You can explicitly set that in your YAML file. And then you also want to prevent your containers running as root. Last thing to keep in mind, it's always best to group your policies together. So as you're dealing with different Helm charts, if you see pod security policies in different YAML files, it is a best practice to kind of store them all in one place so you don't lose track of them. I mentioned pod access. So you can read this, but the desired state of each cluster is highly configurable. And with Helm and Kubernetes, you would use role-based access control. With role-based access control, you set a role for a user or a group, and then a role or a cluster role. And then you use a role binding or a cluster role binding to assign these roles to the namespace. So in this example, you can see I have a user named Ruby, and I've defined a role using my RBAC, my pod policies. And then with the role binding, I am assigning this user to this namespace. Roles apply to one specific namespace. Cluster roles apply to all namespaces. Service accounts are like basically, they're like system created human IDs, and they help you manage the objects that talk to the API server. And these service accounts can also be used, just like you're giving roles to the human counterpart, to define permissions for your services. Okay, so network policies. This is, so sort of in the 𝗗𝗲𝗃 chart, I'm just showing you that at the bottom, there is a key value pair for network policy. This, it's not enabled here, but I want you to see where this information actually lives in real world charts. And a network policy is basically a specification that defines how a pod or a group of pod can get incoming and outgoing traffic. So Kubernetes assigns each pod a unique IP address, and you can use that IP address as well as the concept of a label to tell the pod what the ingress and egress traffic is, which just basically means the incoming and outgoing traffic from a pod to another pod, or from the pod to something inside or outside the network. Okay, secrets management. So this sounds really obvious, but this is actually one of the biggest mistakes that we see in Helm charts is don't store secret information or sensitive information in public. Don't put them in config maps. Config maps and secrets files are pretty much the same thing, but your secrets file is where you would put your sensitive data. Your config maps will have key value pairs that do other things. Don't put sensitive information somewhere where it's just exposed. So when we talk about, protecting this sensitive information, there's a few sort of steps in this philosophical approach to secrets management. So One, depending on what services you're using for your applications, it's good to set up logging and monitoring tools to also monitor your secrets. I'm going to show you a little bit more about step 2, which is encoding and encrypting secrets. You should also, as a best practice, rotate secrets and sensitive information regularly. There are tools that can help you do this in an easy way. And of course, just like your pod security policies, you should isolate where your secrets are stored. They shouldn't be, inside these other YAML files. It's best to isolate them, put them in a different place. So one tool to do secrets management that the Helm community uses pretty often is the Helm Secrets plugin. It can be used for username and password, database credentials, encryption of any of this sensitive information. Basically, you do a Helm plugin install. When you use the Helm Secrets plugin, there is a prerequisite step, which is a system called SOPs. So make sure that you're using SOPs. On a Mac, it's brew install SOPs. You set up your Helm_vars folder, and you put your YAML declarations for SOPs that point to your secrets files in here. Then you, in your, say, secrets file, you would put all your sensitive information in there. You would encode it with base64, and then with the Helm Secrets plugin installed, you just do this simple command, Helm Secrets enc, and then you point to your secrets.yaml file. You'll see in your terminal, it'll spit out that it's encrypted the secret. Now, I mentioned that secrets management, one of the best practices is rotating your credentials. The Helm Secrets plugin is just there to encrypt. It's not going to help you with some of the other best practices for secrets management. So one recommendation is to check out the HashiCorp Vault tool for secrets management. It's much more in-depth. It can manage your secrets in various states, but it is a higher overhead to set up. But for a production level case, especially when you have a lot of different sensitive information, this is one of the recommended tools to use. Okay, next is very simply some Helm commands. I think it's always important as a step in Helm security to make sure that you do Helm lint. The linter will just go through the structure of the chart that you created or adapted, and it'll spit out this simple explanation. It'll say 1 chart linted or however many charts, and 0 charts failed, hopefully. I actually recently did a webinar where I did the Helm lint and realized there was a minor issue in the chart that was going to affect my deployment. So again, just Helm lint it, easy. It'll tell you the state of the Helm chart you created. Certificates. So, as a best practice, you should always make sure that data is encrypted, not just at rest, but also in transit. So certificates are used to, they're used to provide permissions to sort of the user that is accessing etcd. And one of the most common ways to do certificate management is this tool called Cert Manager by JetStack. And installing Cert Manager is actually relatively easy. So I spoke a little bit about Helm Center, which I will show you, but you can install Cert Manager directly from Helm Center. This is sort of the steps to do so. You install your custom resource definition, then you give Cert Manager a namespace like Cert Manager, and then you do the installation and the rollout. Last is dependency and mitigation tools. So this is actually why I had mentioned your subchart folder. When you are checking your Helm chart dependencies, in some cases, you can actually change those dependencies. You can change sometimes the subcharts that are part of this application. You would do so in your subchart folder. So you should use a trusted registry like ChartCenter, because ChartCenter will give you a full view into vulnerabilities in your dependencies. It'll provide you any CVEs, which stands for Common Vulnerability and Exposures data. Any CVEs, CVEs are an ID given to a vulnerability. It'll show you those CVEs in Helm Center itself. So as you can see on the security tab for each chart, it lists the CVE, the severity, the container image, the component where this where this issue lives. And this is going to help you choose the right Helm chart, the right Helm chart version, and do any mitigation that you want to do. We also have a tool for chart maintainers called the securitymitigation.yaml. The chart maintainer can actually communicate on our UI with the end user and provide any mitigation notes around CVEs on their charts. And this is the spec for that YAML file. And this is an example of what it looks like on the UI. This is the maintainer notes. And lastly, deploying your chart. So I recently deployed a chart using Rancher. And so I created my chart, I signed and packaged it, I put it in JFrog container registry, and I deployed it on Rancher. And your service providers like Rancher can also provide options that help secure your charts. So this isn't about Rancher, but they do have some cool tools on their UI that also increase the security of your chart. So that's how Helm charts create reproducible security. I went through each step kind of in this fun graphic view, and this was the blueprint. Okay, so that's the end of my presentation. Wanted to know if we should take questions now or wait till the end of the next talk.
Yeah, let me check on the YouTube channel, Deep. And in fact, I can also post over there. So I don't see any questions at the moment, but what we can do is I'm going to ask folks and everybody online, of course, please post your questions directly on YouTube. And what we'll do is we'll come back to this and go a little bit deeper and look at the questions after the next topic.
Okay, great. So if anyone does have any questions after this talk, please reach out to me, deepd@jfrog.com. Thank you, and looking forward to the next talk.
Yeah, thank you, Deep. Great overview and of Helm and all of the powerful features that it helps enable. So what I'm going to do is let me share my screen, and what I'll show is I want to deeper dive into one aspect of the of the security, right? And we'll come back to ChartCenter. We'll actually do some live demo and download a chart and look at some of the types of issues you should be on the lookout for as you look at different charts from different repos, etc. So just to kind of set the context for what I'm going to cover is go into, and Deep touched on a few topics around this, like even, resource quotas, looking at pod security policies. But I think that, what I want to do is go one level deeper, especially if you're creating charts or using charts in production, which are, authored by third-party vendors. You want to do some deeper scanning and inspections, right? So first off, if you think about security, and it's interesting because we tend to sort of think about these more complex, or let's say deep sort of schemes that people may be coming up with to for hacks or for security vulnerabilities, things like that. But in most cases, configuration and misconfiguration happens to be the most common cause of securities, right? And security vulnerabilities. And if you think about it, I mean, it makes sense, right? Because if somebody's scanning for any sort of vulnerable sites, looking at things, they don't have time. They're not gonna have the patience to come up with some complex scheme in order to hack in or break into a system. They're looking for common misconfigurations, things, very simple things to do, which are not often done. And they're going to exploit those. So this is something that has happened with Kubernetes and will continue to happen, right? And we've seen several examples of this in cloud-based systems where it's extremely simple misconfigurations that cause the most severe security problems, right? Now, thinking about this in Kubernetes, I mean, Kubernetes, of course, takes configuration to the next level, right? And this is what we love about Kubernetes. So here's a simple chart, right, which is for a Nginx controller, and it translates to about 1,000 lines of YAML. And there's a lot of, I mean, it's not, no particular piece here is complex by itself, but there's just a lot to go through, and there's a lot of YAML and a lot of definitions which are sort of included in this. And of course, this is what makes Kubernetes so powerful, the declarative configuration management, the fact that it's so flexible that you can configure any aspect of the system, but yet that perhaps is what also leads to the complexity in Kubernetes, right? There's a daunting amount of things to configure, to manage, to be able to deploy and use any workload. So certainly, there needs to be a better solution. And interestingly, Kubernetes also gives us some of these solutions, right? So first off, Helm itself, fantastic solution from the community where you can take some of these, configurations or package a lot of these common configurations like Deep went through, include them in a bundle. So now you have one, sort of, package to manage instead of these thousands of lines of YAML with different configuration objects that you need to think through. But really, how do you know what you're getting, right? So how do how do you know that the authors of the chart have really gone through and taken care of the best practices and the ever evolving set of best practices, we should say, in the Kubernetes community, right? So there's things like, for example, one of the things I'll talk about is also the evolution of pod security policies and where that's headed. So just first off, quick introduction to myself. Like I mentioned at the top of the hour, I'm Jim 𝗗𝗲𝗽. I'm a co-founder and the CEO at Nirmata. And I've been working with Kubernetes for the past four or so years. And lately I've been contributing most in the policy working group, also the multi-tenancy working group. So certainly, reach out on those communities. There's a lot of interesting things going on in the community as we are all working to evolve Kubernetes to the next level, right? Make it easier to use, easier to manage at scale, and also fit into more enterprise use cases. So thinking about security, just a very, very kind of high level rough view of Kubernetes, or I guess you could apply this to any platform as a service type of technology. So you have, if you think about a DevOps pipeline, you want to do a certain level of security outside your running environments, right? So these are things like what ChartCenter enables with the pretty awesome integration with X-ray and other tools, where you can easily see for any chart what the vulnerabilities are, what happens. So image scanning, most folks in the community and most customers that we work with, image scanning is something that everybody understands that must be done, must be part of their CI/CD and DevOps process. The next step is, before you bring something into your cluster, into your domain, you want to make sure that you have the right permissions, like things like RBAC, etc. And that again is a well understood thing. And then more and more, sort of folks are realizing that also within the cluster, you need to look for, have some runtime security tools, whether it's tools like, 𝗗𝗲𝗲𝗽 security or Sysdig, Falco, or other projects, which are constantly looking for, interesting events and occurrences inside of the cluster. But along with that, what I want to kind of emphasize is, again, going back to the premise that configuration is the number one source of security problems, or misconfigurations, I should say. You need to now layer in configuration validation, configuration enforcement, and scanning for each one of these phases, right? So what's important is, because of this, again, the declarative configuration management in Kubernetes, the daunting amount of configuration and the complexity of it, more and more, the idea is that you want to automate this and just really make this part of your entire tool chain rather than this being an afterthought, right? And as Deep mentioned, like, tools like Nirmata and others, what we do beyond, just as we're deploying and managing environments and clusters at scale, is we provide these type of features out of the box to make this easy. And what I'll show is how we're doing that through one of our open source projects, Kyverno, which is a policy engine. So let me step back and talk a little bit about PSPs and pod security policies, because it's interesting, again, as Kubernetes evolves, and it is a fast moving project. So There's lots of ideas and great ideas that come in, and not every one of them makes it to GA, right? So with PSPs, they're currently within the community, the discussions and where things are. PSPs are currently, I believe, a beta feature, if I'm not mistaken. Um, and there's no plans to move them further into GA, right? Um, or they might actually be an alpha feature. I'm not sure which one of those, but and the reasoning why PSPs are not being moved to sort of a GA state or a stable state is because the real world experience has been, so first off, PSPs tie into RBAC and auth control, and they're fairly complex to configure and manage at scale, and you end up with several different levels of policies for different types of pods, and somebody has to manage all of that, which is fairly complex. The other aspect of PSPs, and perhaps this is the main issue, is if you have an existing cluster and existing workloads, there really is no proper way to roll out PSPs. It's like all or nothing, right? So and if you enable them, immediately your workloads which are non-compliant are going to break, right? So clearly that's not a good thing that you want to do with your clusters, or in the feedback and the discussions. And these are discussions in like SIG security and other, SIGAuth and other groups within the CNCF, has been that this is, practically speaking, it's not very usable, right? So one of the replacements being discussed is to standardize pod security profiles. And I'll just quickly show what these look like. I'll just pull up a link. There is a Google Doc out there, and feel free to reach out, if you want the link. It will be in the presentation. But this discusses the different types of profiles, and it's a very, pretty good proposal where the idea is that you have privileged, baseline, and restricted types of workloads, and then you're looking at, compliance to that profile, right? So then the problem becomes is like, how are you now checking for compliance to that profile, and how do you do that in the various phases of your life cycle? And that's where there's a growing sort of set of policy engines which are very capable, which are able to do this across different phases. And I'm going to focus on Kyverno. OPA Gatekeeper is perhaps the better known policy engine, but there are some limitations with that, which is why we designed and built Kyverno, which is a more Kubernetes native policy engine and can manage these requirements across all three phases that we talked about. So just briefly, a couple of quick slides on, to set the context on what Kyverno is. So Kyverno works as an admission controller. And what that will let you do is basically with every API request, there's an admission review request that comes in from the API server to your registered admission controllers. And admission controllers can be validating or mutating. So in this case, Kyverno has policies and features to either validate, mutate, generate configurations dynamically on the fly. And then Kyverno will send back a response to the admission server based on your policies. All of this is cached in memory for fast access. It is very much optimized for Kubernetes. So it's not a general purpose policy engine, but it's a Kubernetes native policy engine. Policies are very simple resources, and I'll show what it takes to manage through that. And the structure of a policy is very straightforward too. So you have a policy with several rules. Rules can be matched and excluded based on the resource filters. So based on your admission review request. And then you can mutate, validate, generate different configurations, right? So really that's the basics of Kyverno. And rather than spend more time kind of looking at this in PowerPoint, what I want to do is just show you how this works in action, right? And what we're going to do for that is, we're going to use the Kyverno CLI for CI/CD scanning. We're going to use the admission controller to do, to block certain, requests. And then we're going to use the scanner mode, which will also pick up violations and existing workloads. Say your admission controller is down, somebody did something, you also want to do background scanning, right? So admission control is not enough. So this is how Kyverno covers all three phases that we would be interested in. So let me switch to my terminal. And what I'm going to do is I'm going to start out by installing Kyverno, right? And this is pretty straightforward. So if we go to the Kyverno website itself, over here, there's a one-line sort of command. There's a Helm chart also if you prefer using that. But what I'm going to do is I'm just going to, for this demo, I'll just use this one-line command to basically install cluster. So here I have, if I do kubectl get namespace, I have my, this is on my Windows laptop, so I have Docker for Windows running, that's running Kubernetes, and I'm just going to install Kyverno through this one-line command. So it downloads a bunch of things. It brings up, so we'll see if we do kubectl get namespace, we should see now a Kyverno namespace. If we do -n Kyverno, and we'll look at the workloads. So there's a pod running, and that's really all it takes to install Kyverno, right? But now at this point, if I do, kubectl get cpol, which is cluster policies, or a short abbreviation for cluster policies, I don't have, any policies installed right now, right? So at this point in my, in my workspace, because there's no cluster policies, it's saying that there's nothing found. So what I'm going to do is on the Kyverno website, you can find a number of different best practice policies, and I'm going to install those, and then we're going to try and install some charts with those and see what happens. And the ones that I'm going to install, I'll show you how to find them. If you go to the Kyverno website, you can see there's about 17 different best practice policies, everything, and which cover a lot of what PSPs do, but they go a lot further also, right? And these are things you can customize. So if you want to even have very fine-grained granular policies, that's possible to do. So I have a folder downloaded with the, for all of these. And the only change I made to these policies by default, when you look at these policies on the Kyverno website, all of these policies are in audit mode. But what the change I made, and this is if I show you the same policy that I have locally, I have changed this to enforce mode, right? So what this means is now when these policies are applied, Kyverno will enforce these policies as a mission control, which is the first test I want to show. So I'll go ahead and let's apply these policies. And once they're applied, what I will do is let's go to ChartCenter and let's pick a Helm chart, right? So I think Deep talk about 𝗗𝗲𝗽 as a chart. So if you look at this, in Helm Center, what we see is a lot of information, including this awesome security tab. We see the vulnerabilities, so this is fantastic, right? It shows us a lot of good stuff and helpful information directly about what we might want to improve in this chart before we run it in production. But all I want to do is I want to try and install this, and if everything works as expected, what should happen is we get some feedback from Kyverno on whether this chart can be installed or not in the cluster. So the YAMLs were downloaded, and now that was sent to the API server through the admission controllers. And what we see is Kyverno, as a validating webhook, denied that request. And it said, hey, there's a few things in this chart which you probably want to look at, right, and improve on, right? So there's the one thing, of course, and sometimes there are good reasons why some of the chart authors prefer or use these. Like, for example, if you install the Nginx ingress, by default, the Nginx ingress also has privilege escalation set to true. Now, this might be surprising. It's like, why do I need that for my ingress controller? The reason is, and there's a Git ticket on this which describes why. It's because by default, the TCP mode and UDP mode are supported. And for those, you need some escalated privileges for the lower ports on your system. So because of that, the authors decided to allow that by default. But this is good information to know before you install that ingress. And of course, if you are not using TCP and UDP, like about 80% of the use cases for Nginx as an ingress would be HTTP, so or perhaps even more. So in that case, you can turn that off, and you can safely turn that off without impacting any functionality. So, but just looking at some of the errors that we saw over here, what's interesting is the first off, there's privilege escalation in one of the resources, which is what this is pointing out, and it's telling us which container, which security context. It's also there's run as root also is being flagged, and then of course like things like the root file system, etc. For some of these. So these type of issues are what you want to easily be able to detect. And also now it's like, okay, if you find this, what do you do and how do you decide whether you want to proceed with that? So that's something that you want to evaluate. But one thing I also want to show is if I want to go back and let's say I change all of these, from enforce, I want to flip them back to audit mode. What will happen is I can replace change all of these policies to audit mode. And let's go ahead and reapply those. Because these are Kubernetes resources, I'm just using kubectl to manage my policies, right? And in this case, what should happen is we'll try and run that chart again. And this time Kyverno will not flag these or not block during admission control. But what you'll see, it'll take a few minutes for Kyverno to do a full scan. Oh, it's saying it, yeah, let's put this in a namespace. Or actually, let's just say list, whoops. And we can uninstall this. Oops. So I'll uninstall this previous chart and we'll try that again, right? And the expectation is this time, when we run, we should be able to install this chart with no issues, but then Kyverno should produce a background scan and a policy report to be able to, for administrators to see things that they might want to improve. So the idea is on your dev test clusters or even in select namespaces on the same cluster, you can enable the audit mode, but then you can enforce for certain workloads for certain things where you're very strict about what type of configuration to allow and not, right? So as you see now, this is installed, it's running, it's giving us a message for how to use Git. So all good in terms of what we want to do over here. The last thing I want to show is, of course, there's a Helm template command, right? And I talked about, the other place where you want to try and validate your best practices is not just during admission control, but you want to do this as early as possible. So how would you do that with Kyverno? And for that, what I'm going to do is I'm going to use a Kyverno CLI. So we're going to use this command where I'm going to apply all of the best practice policies, but I want to apply it to I previously downloaded and used Helm template to expand out that same chart into a YAML file, right? So this is a pretty large YAML file, but what we can do is actually, so yeah, I'll paste that and then I'll say -r for the resource. And I'm going to do ctemp and then this is the YAML file where I saved the output from Helm template. So if I run this, what I should see is a lot of different output. And I actually see now like there's Kyverno mutate policies, which this is an interesting one I want to highlight, which often catches folks by surprise, right? So if I go back up here, one of the things it said is it's added the safe to evict label onto a deployment. Now, one thing which in Kubernetes, of course, you have autoscalers, node autoscalers, which can scale up or scale down your cluster. And something that's not often known is if your pod uses things like hoster or emptydir in the volumes, what happens is the autoscaler cannot evict that pod. So sure enough, this one is using emptydir. And because of, so it cannot evict the pod if you're trying to drain or cordon the node, if you're trying to scale down. So to help the autoscaler, what you need to do is you need to add an annotation, which is what Kyverno did automatically for us over here, which said it added this, safe to evict annotation for the cluster autoscaler because host dir was set, right? So this is one of the best practices that you should follow. Now, it's not necessarily security related, but it's, just lessons learned from operating Kubernetes clusters and something that you want to make sure you have for some of these charts and things which may be using empty dir, which may be using host dir. Now, host dir may be something you just want to completely block, because if a pod can or a workload can access host dir, potentially they could leverage that for other exploits because they can now get to the host. But empty dir is a safe construct, but even then, that could prevent your scaling down of nodes, right? So it's something that you want to kind of see. So that's the last thing I wanted to show, and how this can be done just through a command line. There's a kubectl plugin which does this through for Kyverno, and there's a lot of other, kind of, some of these, of course, don't apply because you can easily give a namespace, but others which you may want to kind of verify and use in your particular deployment itself. So with that, let me go back to the PowerPoint and quickly wrap up. I know we're at the top of the hour. So what we looked at is how to use Kyverno for configuration, a deeper look into a chart, and really figuring out configuration issues, best practices we may want to follow. And Kyverno can be used across your entire pipeline. So everything at the CI/CD to admission controls to runtime scans. So the chart that we installed, if I go back and if I just look at also runtime, so if I do kubectl and if I do get policy violations, what I should see is a number of different policy violations generated for these charts, right? So that's how Kyverno handles that. Nirmata, the solution that we build, it's a multi-cluster, multi-cloud Kubernetes manager, which can also bundles in and makes Kyverno super easy to use across multiple clusters. And both of these are, of course, free to try out. So definitely check out Kyverno at the GitHub project. And also for Nirmata, you can go to try.nirmata.io. And certainly for any other questions or follow-ups, feel free to contact me either through email, on Twitter, or on LinkedIn. So with that, let's check if there's any questions and that we can help.
Jim, there are some questions on YouTube. I'll just repeat them just for your reference, and you can answer those. The first question is there a GUI to monitor policy deployment and matrices?
Yes, so that is exactly what Nirmata does, and I'll just quickly show what that dashboard looks like. So in Nirmata, if you kind of look at different workload policies installed on one of my clusters, this is an example of that. And you can here drill down and see like where the violations are and how you want to kind of assess and process those.
Okay, perfect. So another question is, will Kyverno default policies help Kubernetes clusters meet CIS benchmarks?
Some of them, right? So some configuration best practices, yes, it will help, but Kubernetes benchmarks, CIS benchmarks also configure or look at things like which API server flags to enable, how your nodes should be configured. Those Kyverno will not be able to handle because Kyverno operates inside the cluster. So anything inside the cluster can be scanned. If you're looking for a tool, for to do the Kubernetes benchmark, KubeBench is probably one of the best tools for that. And there is some work going on in the policy working group to converge on the reporting format from Kyverno and KubeBench and produce common policy reports which can be consumed upstream.
Great. So I know we are over time. There's one last question. I think this is again related to Kyverno. So it says, can we force evict without any callbacks? And this might be related to evicting pods from nodes, but not sure from how this
Yeah,
fits in
not
with Kubernetes.
sure. Oh, so without any callbacks like into the pod lifecycle? Not sure. Yeah, I don't know. Like, of course, there are, some hooks now you can have in the pod to handle with like either some events like eviction or a shutdown. So I'm not sure if, so I know like from kubectl you can do force and you could say, the grace period as 0, so that will force the evict right away. But I'd have to check and see what exactly the behavior would be during the auto scaling component.
Awesome. I think that's all for the questions. Jim, Deep, thank you. And I think that's probably going to end this live stream. Again, folks, if you have any questions, the contact information for Deep and Jim was posted as part of the presentation. So please feel free to reach out. And we will continue to host meetups. If you, please also send us suggestions for other topics that you'd be interested in. You can post a comment or, again, email in the meetup group. And would definitely love to cover some of those topics in our upcoming meetups. All right. Thank you. Thank you, everybody.
Thanks. Bye-bye.